Alright, these are your notes for working with radicals, and in this particular video we're going to learn how to multiply radicals together. We've already learned how to simplify them. The reason we learn how to simplify first is because we have to simplify when we multiply them. So we need to use that skill from the first video in this one. Alright, but we're going to learn how to multiply radicals together. Now there's a couple steps. There's 3 steps that you want to do when you multiply radicals together. Step 1 is to try to simplify first. And the reason you want to try to simplify first is that it will make your number smaller. If you don't simplify first, you can get some huge radicands, some huge numbers underneath the radical sign. You can get things in the thousands. So it's always a good idea to simplify first. If you simplify first, that keeps your radicand smaller. And you may not have to simplify it again. It may not break down. So it's a great idea to simplify first. That should be the first thing you do when you see these problems. The second step is to multiply them together, and there's 2 parts to this. The first thing you want to do is multiply the numbers out in front together of the 2 radicands, the 2 radical expressions. And then the second thing is to multiply the 2 radicands together. When you do that, that gets you to the third step, and you have a new radical, a new answer, and you want to try to simplify it again. This is where that third step, it's a great idea to simplify in the very beginning, because in that third step, if you didn't simplify first, you can end up with some huge numbers. Okay? So we're going to look at some examples. We're going to jump right into this. We have 6 to look at. First example here is the square root of 10 times the square root of 2. We want to check and see if we can break these down. 10 is 2 and 5, neither of which is a perfect square, and 2 is just 2 and 1. It's not going to break down, so we can't break either of these down. That means we go ahead and multiply them together. Now there's a 1 out in front of each one of these, because remember, we need to multiply the numbers out in front and the numbers that are the radicands together. If there's nothing written out in front, it's understood to be a 1, so keep that in mind. Well, 1 times 1 is 1, and 10 times 2 is 20. So there's our new answer. We have 1 square roots of 20. We don't have to rewrite that 1. Okay? It's not necessary to put that in the problem if there's a 1 out in front. It's understood that it's there. So really we have the square root of 20. Now we're to step 3. We need to see if we can break 20 down. Is there a perfect square that goes into 20? Yeah, there is. It's 4. I'm going to circle my 4 because it's the perfect square. The square root of 4 is 2. And then the 5 is not a perfect square, so it stays underneath. And there would be the answer to our problem, 2 square roots of 5. Now, it's not that difficult. That was a pretty easy problem. I will warn you, the ones you have in class will be some odd numbers, some weird answers where you're going to have to think a little harder than just the square root of 20. Okay? Let's look at the next one. Next example is the square root of 10 times the square root of 8. Let's try to break it down. Well, we figured out that the square root of 10 wouldn't break down in our first example, so I'm going to leave that. Let's try to break down 8. 8 is 4 and 2. 4 is a perfect square, so it becomes 2, which is the square root of 4, root 2. And that 2 stayed underneath the radical sign because it wasn't a perfect square. So now we're left with the square root of 10 times 2 square roots of 2. We multiply these together. Remember, there's a 1 out in front of that square root of 10. 2 times 1 is 2. And 10 times 2 is 20. Now we're going to break down our 20. We did that before. Square root of 2 is 2. I already had a 2 out in front. I can't forget it. 5 stays underneath. Remember, these get multiplied together when I have more than one thing out in front. 2 times 2 is 4. Square roots of 5. And there's our answer to this problem. Okay? Now, if I didn't simplify first, I would have had the square root of 80, and then I would have to go through and find the biggest perfect square that goes into 80. It's not wrong to do it that way. I just have a bigger number to deal with. Okay? So look at our third example. Square root of 20 times the square root of 8. Let's simplify these. Now I'm going to save some time. We've broken these down in the 2 previous problems. The square root of 8 in the second example became 2 square roots of 2. And the square root of 20 was the unsimplified answer to example 1, and it became 2 square roots of 5. All right? So I pulled those from the other two problems. If I don't remember what they are, then I would have to simplify them on my own. But in this case, I can use the previous problems, which is a good idea, a good test taking or homework tip. Watch what you're doing, think about what you're doing, because you may solve parts of other problems when you're doing your homework. Okay? Now that they're simplified, we're going to multiply them together. The numbers out in front, 2 and 2. 2 times 2 is 4. The radicands, 5 and 2. 5 times 2 is 10. 10 won't break down. It's just 2 and 5, neither of which is a perfect square. So our answer is 4 square roots of 10. All right? Let's go on to the next example. We have 3 more. Fourth example here. 2 square roots of 3 times the square root of 6. Now I know 3 isn't going to break down. 3 is prime. I can't get a perfect square. 6 breaks down into 2 and 3, and neither of those are perfect squares. So they're already simplified. I'm going to go ahead and multiply them together. Remember, there's a 1 out in front of that square root 6. I can't forget about it. 2 times 1, my numbers out in front are 2. And then 3 times 6, my numbers underneath, my radicands, give me 18. Now we got to see if we can break 18 down. 18 breaks down into 9 and 2. 9 is a perfect square. The square root of 9 is 3. So 3 is going out in front. I need to multiply these together because they're both out in front. 2 times 3 is 6. Square root of 2. And there's my answer to the problem. 6 square roots of 2. Got another example here. Example 5. 3 square roots of 5 times 2 square roots of 6. Now, both of them have numbers out in front. The radicands were already simplified on both. 5 is prime, and we said earlier we couldn't break 6 down. Again, that's paying attention to what you're doing. So we can go ahead and multiply them. 3 times 2 is 6. 5 times 6 is 30. Now, to break down 30, we get 5 and 6. Neither of which is a perfect square. 6 is 2 and 3. I still don't have any perfect squares, so it's simplified the way that it is. We just get 6 square roots of 30. So in that particular example, we didn't have to simplify in the beginning. We multiplied together, and we didn't have to simplify at the end. So that was a nice example. All I had to do was multiply. You don't know about that, though, until you've actually done the problem. So be sure to always check all 3 steps. See if you can simplify first, multiply, and see if you can simplify at the end. Alright, one more example here, and this one's a little different. I'm going to put a star by this one. You have 2 square roots of 7 in parentheses squared. Now this is a tricky problem. What you do, you can't just distribute the square through. That doesn't work. What we do is we rewrite it next to itself. Like this. If we think about something like 5 squared, that's really 5 times 5. That's how we would solve it. So we use the same idea here. If we have 2 square roots of 7 in parentheses squared, all we do is take that times itself. Now we have a problem like we would in the other 5. It's the same idea. Check to see if we can simplify. We can't. The 7 is already a prime number. It won't break down. There's no perfect squares. So we go ahead and multiply. Multiply the numbers out in front. 2 times 2 is 4. The radicand, 7 times 7 gives us 49. Now 49 is already a perfect square. It's not gonna. It's a perfect square in itself. I don't have to break it down at all. So I'm just gonna circle it. I'm gonna circle 49. Then square root of 49 is 7. Now what happens is my square root disappears. It's gone because I took the radicand. The radicand was a perfect square itself, so the radical just disappears. And 4 times 7, because I got to multiply them together, is 28. So in that case, I got a whole number as my answer. It has no radical on it. And that may happen, so pay attention to that. It's okay to get that as an answer. So those are your notes on multiplying radicals together. If you have any questions, rewatch the video or bring them to class next time.